Hey everyone, welcome back. So till now we have solved most of the problem based on array, and today we are going to start one of the most important topic, which is binary search. So before understanding the binary search, you should know what is the linear search. So you can think a linear search as a searching technique, means you have a element x, let's take 5, and if you have an array like this and you have to find 5 is available in this array or not. So what you can do, if you do not know any techniques, you just iterate over the array, right? You will run a loop and iterate over every single value and compare the value with the x. So if you able to find your value, that means that value is available. So linear search is basically a technique in which you are trying to compare with every value in the array. So let's take another example. Let's say if you have f equals to 3, right? So in the array, computer does not know where is the 3. So you will start iterating from the 0th index and compare, is 1 equals to 3? No. Then you will move 5 equals to 3? No. Then you will move 2 equals to 3? No. You will move 3 equals to 3? Yes. So this is our answer. So in linear search, we try to compare with every single element in the array. So if you write a code for linear search, it will be like this. You will run a loop from 0th index to the last index and compare. If your value is equals to x, then you can return that index, right? So this is our code for the linear search, means you will be comparing with every single value in the array. So the time complexity will be big of n, right? Because we are iterating over the array. But now we want our searching in the time complexity of log n. So the binary search is the optimized concept of the linear search, where we try to find a value in a log n time complexity. So let's see how this works. So we have this example and we have target equals to 9. So you have to find this target in the array. So let's take two pointer here. Here we will take low and here we will take high, and we will find a mid, which will be low plus high by 2. So our low is 0 because it is at the 0th index, and our high is at the 5th index, so it will be 2. So our mid will be at this index. Now we will compare, is our target is equals to this value at the mid, means we have 3 is equals to 9? No, right? So we will move our low next to the mid. Now we will find mid again, which is low is at the index of 3 plus our high is at the index of 5. It will be 4, right? So our mid will move at the 4th index. Now we will compare 9 equals to 9. Condition true, we can say we were able to find our value. Now how many iteration we have took? 1, 2, right? We have array size of 5, but we only took 2 iteration to find our value. So in binary search, at every iteration we are dividing the array, means initially we had this whole array to search, but our mid was here and we checked this 3 is smaller than this target, right? That means we can only find our 9 to the right side. If we know 9 is only belongs to the right side, we can eliminate values from the left side. So our low will start from this position. So this time we have only this array. Okay, so now the question is, how we are comparing that our 9 will be right side. So binary search concept only works on sorted arrays. If you want to apply binary search, you have to sort your array. In this example, the array is already sorted, right? So every time find the mid, compare the value of the mid to the target. If it is not equals, then you have to compare it is greater or the smaller. So let's take another example. So we have similar example, but this time we have target 2. Now we will start low, high, and we will find our mid. So 0 plus 5 by 2, it will be 2, right? So our mid will be here. Now we will compare 3 equals to 2? No. Now if our 3 is not equals to 2, we have to compare, is 3 smaller than 2? No, it is not. That means our 3 is greater than 2. If it is greater than 2, that means our 2 lies somewhere to the left side, right? Because if you go to the right side, all the elements are in increasing order, so 2 isn't possible in that range. So we have to find our 2 in the left range. So that means if we want to move to the left range, we will pick our high from here and move high here. So how we are moving it? So our high will be mid minus 1, right? Now we will find mid again. So 0 plus 1 by 2, it will be 0, right? So our mid will come at the 0th index. Now we will again compare, is minus 1 equals to 2? No. Minus 1 less than 2? True. That means we need a bigger value. If we need a bigger value, that means we have to go to the right side. So our low will move to the right side. So if we want to move our low to the right side, we will write low equals to mid plus 1. Now as I moved my low, it overlaps with the high. Now let's find the mid. Mid equals to 1 plus 1, it will be 1. So our mid also will be sitting at the same index. Now we will find again, is 0 equals to 2? No. 0 less than 2? Yes. That means we need a bigger value. If we need a bigger value, that means we have to move to the right side. So again we will move our low. So if we move our low here, that means we weren't able to find our value because our low crossed high. They crossed. That means we searched every value and we weren't able to find our value. So we will return minus 1 in this case. So for this, you can take a real world example of the book. In the book, if you want to search a page 236, right? So initially you randomly open a book, right? So it may happen you will be end up to the page number 400. Now you know that 236 is smaller than 400. So you will go to the left side. So if you open again at the left side, you will be maybe end up at the 200, right? Now 236 is greater than 200. That means you have to again go to the right. So you open the page at around 230. Now 230 is smaller than 236. Then you again go to the right. So you will be able to open your page number 236. So basically you are going to the side where the possibility of having element is more, right? So if you need a bigger value compared to your value, you will be going to the right. If you want a smaller value compared to your value, you will be going to the left. So let's take one more example so it will be clear to you. So this time our target is 2, right? So we will take our low here, high here, and we will find our mid, which will be 0 plus 5, okay, and 2, it will be 2. So our mid will come here and we will compare 5 equals to 2. No. 5 smaller than 2. No. 5 greater than 2. True. That means we need a smaller value. So we will move our high to the left. So high equals to mid minus 1, right? Because we want to move to the left. So our high will come here. Now we again find the mid. 0 plus 1, it will be 0. So our mid will be at the low, and then we again compare 0 equals to 2. No. 0 less than 2. True. That means we will be moving to the right side. So low equals to mid plus 1. So our low will come at this position. Now again we will find mid. So mid equals to 1 plus 1, it will be 1, right? So our mid also will be end up here. Again we will compare 2 equals to true. Yes. So we were able to find our answer at the index 1. Right? So that's how the binary search works. At every iteration, you are shrinking your array to the smaller area. So in that area, you can easily find your value. So let's write a code. So we have given an array of integers and it is sorted in the ascending order, and you have given a target and you have to return index of the target. So we have target 9, so what 9 is at the position 4, so we will print 4. Similarly, in this case our target is not available in the array, so we will be returning -1. Here they are asking to write a algorithm in the log n time complexity, so that means we will be writing binary search. So let's first declare the size of the array. Let's declare our low and high will be n -1, and we will run a loop while low less than equals to high. That means if high becomes greater than low, we will stop our loop. Now we will find here mid low plus high by 2. Now we will compare. If nums of mid equals to target, then we can easily return our mid because mid is at that index. If my nums of mid greater than target, that means we need a smaller value. If we need a smaller value, that means we will move to the left side. So we will shrink our array from the right side. So high equals to mid -1, else we will move to the right side. So low equals to mid plus 1, and if we weren't able to find any index, that means we will return -1. So here you can see our code got accepted. So remember this template, or you can say steps, to write binary search code, because most of the problem will be using same template to write the code. So first we will declare low and high, and we will run a loop which is making sure that we are within the range, and every time we will be finding the mid and comparing our values. Okay, so this is the code for the binary search, and the time complexity is log n, and the space complexity is big of 1. So from now on we are going to focus on the problems based on the binary search, so you will be able to understand. So that's it for today. Until then, thank you everyone, have a nice day.